Hi. In this problem, we are going to look at a question involving straight lines, but actually it turns out that it is a question completely different and it depends on calculus. So a nice question, you will enjoy the solution here. So the question says a line x into a plus b plus y is equal to 1, where a and b are roots of x cubed minus 3x square plus x plus lambda equals 0, and GIF of a plus b is equal to 1, intercepts an area, intercepts a triangle of area A with the coordinate axis. You have to find 2 times maximum area of this triangle. 2a max. So basically, whatever is the area of this triangle that this line intercepts with the coordinate axis, we have to find the maximum area of that triangle, right? So if you look at the line equation, if you imagine the line something like this line equation is in intercept form. We can say it is x by 1 by a plus b plus y by 1 is equal to 1. So this distance is 1, this is the y-intercept, and this distance is 1 by a plus b. And this is a right angle triangle that is intercepted with the axis. So the area of this triangle is going to be half into 1 by a plus b, right? So this is 1 by twice of a plus b. So immediately you should realize that the area of the triangle is 1 by 2 times a plus b. We have to find the maximum value of this area, and that we can only do if we analyze the other parts of the problem, where a and b are roots of this and GIF of a plus b is 1, right? So we have a cubic equation. I will work it out in the next screen. So we have a cubic equation, x cubed minus 3x squared plus x plus lambda is equal to 0. And we know a and b are roots such that GIF of a plus b is equal to 1. So let's say that the 3 roots of this cubic are a, b, and c, right? So by Vieta's relations, sum of the roots a plus b plus c is equal to 3, right? And therefore, we are getting a plus b is equal to 3 minus c. That is one condition. Also, we know that GIF of a plus b is equal to 1. This implies that 1 is less than equal to a plus b less than 2. If the GIF is 1, a plus b value must be bigger than 1, could be equal to 1, but always lesser than 2. So putting this here, 1 is less than 3 minus c less than 2. Subtract 3 minus 2 is less than minus c is less than minus 1, and multiply by minus 1. You get 2 is greater than equal to c is greater than 1. So we are getting the condition on c. C is such that 1 is less than c less than equal to 2. So this is the information that we get about the third root of this cubic, right? And we are getting a plus b is equal to 3 minus c. Why is this important for us? The question asked us to find the area of the triangle, which was coming out to be 1 by 2 times a plus b. But the question did not just ask us to find the area. We also needed to maximize this area, right? So if you try to maximize this area, you will probably need to do some calculus. But the problem is that right now we have two variables a and b. We don't know how to do maximum minimum for two variable functions, right? So our job would be to try to convert it into a function of a single variable, this area, right? So what I can do now is area of the triangle is 1 by 2 times a plus b. And instead of a plus b, I can write 2 times 3 minus c. So this becomes 1 by 6 minus 2c, right? and I need to maximize the area of this. So this is a function of C, and we have already found the range of C. C belongs from 1 to C, 1 to 2, like this. F of C is equal to 1 by 6 minus 2C. Let's maximize it. F dash C will be minus 1 by 6 minus 2C whole square multiplied by minus 2. So it is 2 by 6 minus 2C whole square. So we can see that this is always greater than 0. And that means f of C is increasing function. And if f of C is always increasing over this interval from 1 to 2, fc maximum value will happen at f of 2. So that will become 1 by 6 minus 2 into 2. So that will be 1 by 2. And that is the A max, the maximum value of the area. The question asked us for twice of A max. So our answer is simply 1. So technically the question looks like a straight line problem, but it's actually about maxima minima of a function and also understanding how to handle the roots of a cubic, how to convert the function of two variables a and b into a function involving just c, right? So that is finishes off the problem, and hopefully you've learned something from this video. That's it for this one. I'll see you next time.